What is going on, everyone? Welcome back to the Mathnasium for another video about motors. So strap yourselves in. We're going to be talking about motors. We're going to be doing a little programming, a little wiring going on. Should be able to keep it pretty short and sweet so you guys have plenty of time to do your challenge. So we're dealing with Arduinos, and we can program 3 different types of motors with these Arduinos. Now I'm here to tell you that the motors that you have for these kits are pretty much for little educational applications. You're not going to be doing any crazy heavy lifting or with what we have, but it's a great way to practice and get the basics of the coding and understand what's going on. So there are 3 main kinds of electric motors that we have access to that we can program our Arduinos with. Last time we learned how to create our own motors in class, and we used some wire and a battery and a magnet. There were some key things that we need. We learned the left-hand rule in class, which is the left-hand motor rule. So, make an L, stick your thumb out, and you can follow the magnetic field with your pointer finger, the direction of current with your second finger, and the direction of force or thrust with your thumb. So we were using this to spin our motor in class that we constructed. Now the same principles can be applied to these stream motors. I wanted you to have this as a background for the why. Why does it work? Now we're going to talk about these different motors and kind of their applications. So what we created was a direct current motor, which is kind of what we see here, which might be in anything that's job is really just to spin. So if you just want something to spin over and over and over and over again, a direct current motor is probably the way to go. Now, but if you're desiring something to spin and spin accurately for position, then there's probably a different kind of motor that would better suit your needs. So the regular DC motor is kind of what we created, and you might see a regular DC motor in some kids' toys, or I would say any sort of anything that just is you're not worried about being accurate with the spinning motion. So the other kinds that we might frequently see is something called a servo motor. Now, the servos that we have can only rotate 180 degrees, but they have some benefits. That seems like, hey, what's the big deal? Well, this is really beneficial for things like robotics, because a servo can spin something to a position and place things over and over again. So if you're talking about repeating a task quickly over and over and over again, that's what the servo motor is kind of designed to do. So the definition would be a rotary actuator or linear actuator that allows for precise control of angular, linear position, velocity, and acceleration. So the benefit of a servo is they make 2 kinds of servos. They make ones that can rotate continuously, and we can still specify their degrees. They make these ones that really only can rotate 180 degrees for positioning or something. So the main application here is, doing the same action quickly over and over again. So a servo motor typically has between 4 and 12 magnetic poles that are being controlled to make the turning happen. It has what's called a built-in feedback loop. Now what that means is this servo is self-correcting. So if it notices that it's off, the servo will fix itself. And so you can see you'll see it turn, you might see it kind of correct if it gets off or it gets nudged. It's got a self-correcting system built into it. So if it says that it's supposed to be at, say, 90 degrees, it's going to continuously have a loop that is checking to make sure that it's at 90 degrees. And if it gets off, it will fix itself. The other benefit of a servo motor is you can crank up the speed of a servo motor, and it doesn't necessarily change the force at which that it doesn't really change the torque when it's turning at those high speeds. You get a pretty constant force, which is incredible for accuracy and doing things over long periods of time and doing them quickly. Whereas the next, we're going to contrast this kind of with the next type. Okay, it also is a little more efficient as far as using current, but with these benefits, with a servo motor, you get these benefits. It comes at a cost. It's a little more complex, so they tend to be a little more expensive. These, however, are like, I don't know, $2 or something a piece. I'm talking about like the big servos tend to be a little bit more expensive because of the complexity. But they can do actually a lot more than that. So servos we can specify a specific position, but we can also use them like a potentiometer. We can read their position and make a decision based on their position. So pretty cool. So that is a servo. And then over here we have the next one, which is called a stepper motor. Stepper motors, in contrast, have 50 to 100 magnetic poles. Now, what does this mean, and how is that different than the 4 to 12 that we had before? Well, this allows for a lot of torque, but a stepper motor is not necessarily spinning, continuously. It's spinning in these little steps, and it's doing it so fast that it appears to be continuous. It doesn't have the feedback loop, but it's still very accurate because of the teeth at which it's aligned here. Let's see here. So at lower speeds you can get more torque than you can with a servo, but at higher speeds it drops off like big time. At high speeds this thing does not perform as well as a servo, and it definitely doesn't perform as well as it does at lower speeds. It uses quite a bit more. It's not as efficient with its electricity use, so it's using a constant current. It's a little bit simpler construction, so it's easier to produce, which means it's cheaper. So these are typically a little bit cheaper. So if you're not trying to do things really, really fast and you just want to be, accurate, a stepper motor might be the way to go. And I've included a video on how the stepper motor works, and it's actually, this is the kind of the thumbnail for that video. So here is the speed torque graph for a servo versus a stepper motor. You can see as you increase the RPMs, a servo is still maintaining that same level of force even at a higher RPM, or at least a similar, comparable to what it had before. And then for these two different types of servos, and then a stepper drops off but can achieve overall at slow speeds a much higher torque. So these are in rotations per minute. Okay, so let's take a look. Your program is not going to involve a stepper motor. It'll just involve the servo. The servo is the little blue box that comes in your Arduino kit. And it should also come with kind of like a little peg on there so you can see it twisting. You'll see that here in just a minute when I pull up my program. So let's go over the different functions that a servo can do. Kind of go over some of the basics of what you're going to need to know. So in order for you to use these commands with the servo, these will not work unless you include what's called the servo library. The library is just like, in terms of video games, it's like a DLC for your for a game. So if you're just using the Arduino software as is, it's not going to know these commands. But if you say include servo, then it's going to include a library. So it'll include a collection of verbiage or a collection of language that it understands that is specific for those servos. So it's a collection of functions that are used, imported for a specific use. So you wouldn't have this in every program if you don't need a servo. So you can learn more about these at this website. Let's kind of go over generally what they do. So attach is what connects your servo to your Arduino. Write, it specifies a degree position of the servo to turn to. Write in microseconds does something similar, but it's I think it's maybe a little more accurate. And then read will give you back a position of your servo that you can then use to make a decision because it has that feedback loop. And then attached just returns a Boolean true or false if a servo is connected, and detach, I think it just disconnects it from the circuit, but I don't know if that's probably the opposite of attaching it. So I don't know if that's super important, but or when that would be important in a program. But I know the big one here is write. Write is what specifies when we're going to use to specify the position. So I'm going to go ahead, and now would be a good time for you to get out your Arduinos and assemble the servo circuit from your books. I believe, let me check the circuit number. That is circuit 8. So I'm going to go on Tinkercad so that I can capture my screen. Doing the program, we're going to walk through some of the basic controls and some of the things you can do with the servo, and then I'm going to tell you about your assignment. So here we go, head into Tinkercad. Okay, so here we have our servo set up in all of its glory, and I'm going to make my program a little bit bigger. Hold on. So I have assembled circuit 8, and the wires are maybe in a little different order than they normally would be, but that's okay. And so just make sure that you follow the colors of the wires from your diagram and connect them to the associated positions from the circuit. You can follow my image here, or you can use the one from the book. It's basically the same, except they're in the reverse order. So let's go ahead. I'm going to slide this over. Make sure you have your 5-volt and ground connected. The orange wire is what ends up going to the 9th pin here. And you'll notice the 9th pin has a little squiggly next to it. Remember, that squiggly means pulse width modulation, which means we can turn that port on and off really, really fast. And it is the pulse width modulation that allows us to use the servo. It's using pulse width modulation to specify that position. So it's going to send out a voltage between 0 and 5, and that voltage is going to specify the position in the servo. Okay, I'm going to maybe move this out of the way. I'll let you assemble it. I'm going to kind of zoom in on the code so we can see what's going on. Right, so let's go ahead and jump right in here. So the 3 wires coming out of this servo are power, ground, and signal. Ground obviously goes to ground. Power goes to the 5 volts, so you're just running that 5 volts just to give it the power that it needs. And then the signal wire, which is the orange wire, I think, is what is we're sending in the voltage to control the position. Okay, so let's go over these line by line, kind of talk about what we got going on. Here we go. So the first thing is you have to do this include servo line. Make sure you've got your, your pound sign included there. So just make sure you have this. You don't need the slash there. That's a comment, so not super big deal. You then get to name your servo. I'll just call this servo 1. So the command for naming the servo is just servo, and then the name that you want to give it. Okay, the next thing that we have to do in our setup is we have to say that we are using a servo and in which port. And this is one of the functions from the servo library. So we type servo 1, so we give the name of the servo, whatever it is. If it was servo 2, we would type servo 2 here, dot attach, and then type in the port that it is connected to. And if we zoom out, we can see that we've got that connected to port 9. Okay, so servo1 dot attach, which is one of our functions. Okay, and then we're going to come down here, and it's really easy. We can specify the position. So we say servo1. So anytime you want to do one of these functions, you just say the name of the servo, and then the function that you're going to use. We're going to write it. Okay, we're going to send it to, let's say, 90 degrees. So this will tell the servo to go to 90 degrees. Oops, I used the wrong slashes there. Try that again. Rookie mistake. Tell the servo to go to 90 degrees. Okay? The problem is, remember, this is going to happen very, very, very quickly. So if we want this to happen quickly, then so we need to give the servo time to get into position. So it takes time for it to get to 90 degrees. So we have to kind of give a delay here. So we'll type in a delay. We'll just give it a 1 second delay. And actually, we've written our first servo program. It's that easy. So we can press Start Simulation, and we should see it rotate to 90 degrees, and then it just stays there. It doesn't rotate back. So when you restart the servo, you might need to put it back into position there. This is working a little differently because I'm working in Tinkercad. So I'm going to highlight. I'm going to copy and paste this line, and then I'm going to set it back to 0. So my program is going to set. So this, you're not specifying how many degrees to turn, because this only turns 180. You are specifying a position. So when I say start here, it's going to turn to 90, and then it's going to turn back to 0. And it's that easy. So turn to 90, turn back to 0. And so you can specify. You don't have to go all the way to 90. Maybe you only want to go to 30 or 45. You can specify the degrees, right? And you can go out of order. So maybe I want to go to 90 first, right? And then 30, and then it'll go back to 90 because the loop starts over. So it does 90 first, then it waits, then it goes to 30, then it waits, and then it goes back to 90. So you're specifying the position of that servo. Okay. So that's the first one, or the first thing that we can do with a servo. I think this is a good option for us, or this is a good opportunity for us to also talk about how to use a loop, a for loop. So we're going to take a second to do that as well. So I'm going to stop my program. It's going to kick it back. I'll go to 0, and really we can blank out this code if you want. I'm just going to leave it in there for old time's sake. I'm going to come down, and what we're going to do is we're going to traverse all the positions, which means we're going to kind of cross over all the positions, the degree measurements that the servo can do. And you can do that also. It by default will go to an individual position, but you can specify the rate at which it turns without writing a bunch of delays. So I'm going to kind of specify that for you now. So the first thing you do is we're going to create a variable called int position. Okay, int position. And then what we're going to do is we're going to create a for loop, which means we're going to start at position 0, and we're going to go all the way up to 180, its full rotation. So we'll say for position equals 0. So how a for loop works is you have your starting position indicated for the loop. Then you specify when you want your for loop to loop. We want it to loop while the position is less than or equal to 180 degrees. So I put my equal to in there. So I want to loop while it's less than or equal to 180 degrees. And then I want us to, you specify the increment, which means you specify for each loop. So the for loop, it's going to do this code over and over and over again. We give it its starting position, is position 0, which would be our servo right, okay? We're going to go all the way up to 180. How are we going to go by? So we can say position equals position plus 1. So you can write it that way, or there's maybe a simpler way. If you want to simplify things, I'm all for simplifying things. You can just say position, this is the same logically, position plus equals 1. Position plus equals 1 means every loop, what I want you to do is I want you to add 1 to the variable position. So what are we going to do in each loop? Okay, well the first thing we're going to do is we're going to turn the servo to the position that we want. So we'll say servo 1 dot right position. Okay, servo 1 dot right position, end line, and then we're going to delay. And we can change the delay, and let's keep it really, really short. So what we can do is we can control how it's turning using using a for loop. So this is going to loop. It's going to start at 0, and it's going to loop 181 times. So it starts at position 0, and then it goes to 1, 2, 3, 4, all the way up. It's going to loop each time. So it's position 0, position 1, position 2, position 3, and it's going to wait 20 milliseconds at each position. So it goes to the position, it waits. Goes to the position, it waits. To prevent this code from confusing us, I'm going to come through and I'm going to comment out this code so we don't see this happen, and we're only going to see it traverse through our for loop. Hope this works. Let's give it a run. So you can see it slowly spinning. It's going to spin that 180 degrees, so you guys can specify how that's working. So there's a couple ways we can get it to spin faster. One way that we can get it to spin faster is we can change how many degrees it increases every 20 seconds. So you could say, I want it to increase 2 degrees every 20 milliseconds. Sorry. I want it to increase 2 degrees every 20 milliseconds. The other thing that you could do to increase the rate that it rotates is change the delay between each position. And then we would get, and I think it was lagging there. That's probably due to like internet or something. So you can change the delay and make it rotate faster, is also a way to do it. Okay, so that's a nice round turn. If you want it to be really slow, you could change it to something like 50, the delay to 50. So each time it loops, it's gonna wait 50 milliseconds. Yeah, every single time. So, anyways, that's fantastic. Okay, so that's how you use a servo to specify a degree rotation. So what am I asking you to do for your challenge? This is going to be quite the challenge, maybe for some of you, maybe not for some other people. I'll leave that up to you. What I want you guys to do for your assignment is I want you to plug in a potentiometer. Now you can go to your Arduino book and you can take a look at the potentiometer program for the circuit for the potentiometer program, which is right here. And I go over this program and have attached the potentiometer program and the video on Google Classroom. So you'll be able to watch the lesson on a potentiometer. You can scan through and get what you need. But what I want you to be able to do is I want you to be able to turn the servo with the potentiometer. So you're going to be connecting the potentiometer to an analog in port, and when you turn it, it's going to be changing the position. So you'll need to read the potentiometer, store that in a variable, and then use that variable to alter the position. Now this program is actually fairly short. It's not going to take you long to write. You won't need a for loop. it's basically just going to be a pretty quick little program for you to write. But that's your assignment. That's what I want you to work on. You guys can talk with each other and ask each other for advice. Please feel free to dig through that old potentiometer video. Those that have never used a potentiometer before, I'm going to recommend that you maybe follow my instructions in the potentiometer video before trying to tackle this. But once you get it, I don't think it's going to be too terribly challenging. So if you do the blink speed challenge that we do with the potentiometer program, translating that to the servo should be pretty straightforward. So I hope you guys have enjoyed this video, and yeah, I'm glad that I could be here to servo you in any educational capacity. Okay, I'm gonna stop. That's it. See you next time.